Okay, so what I thought we'd look at is drawing a few strange graphs, give a couple examples, and then give you a few that you can have a go at yourself. So here we go. Um, so let's look at first of all y equals 1 over x squared. Okay, and there's like a couple approaches you can take here. So this is a graph you're not sure what it looks like, right? You know what y equals x squared looks like, but 1 over 1 over x squared is something slightly different. Okay, so there's a couple of approaches. I mean, things you might have seen before are you could draw a table of values, and that's not a bad way to go. Put some x values in here and some y values and kind of get an idea for the shape. But we're going to have a look at a slightly different approach, or a couple of different techniques that you might want to use. So, well, we've been looking at this year. Where does it cross the x-axis and y-axis? That's one thing to look at, isn't it? Any intersection. So we've got the y-axis here, and you know that's where x equals 0, isn't it? And what about the x-axis here, which is where y equals 0? Yeah, everywhere along this axis. So let's have a look at this. Right. So first of all, let's take the x-axis. So when y equals 0, so we've got, if we substitute y equals 0 and we get 0 equals 1 over x squared, if we rearrange that, that implies that 0 equals 1. There's a problem here, isn't there? So like we're thinking, okay, so maybe it doesn't cross the x-axis. Right, what about the y-axis? Okay, well that's when the y-axis when x equals 0. So if we substitute x equals 0, we get y equals 1 over 0 squared, which is 1 over 0, and again, problem. You can't divide by 0. If you put it in your calculator, you'll get maximum error, math error. This is impossible. You can't divide something by nothing. It makes no sense. So we're going to have to take a slightly different approach, right? So let's have a look at what happens when, and this is like one of our new kind of tools, if you like. What happens when x gets really big? Happens when, and then the first thing we'll look at is x gets very big. Okay, so let's think about this. Well, if x gets really big, then 1 over a really big number, if you divide by a massive number, then you're going to get something really small. So as x gets bigger, y is going to get smaller. So it's going to go down in this direction, okay? And it's not going to cross the axis because we looked at that before, didn't we? So it's going to go in this direction. What about when x gets close to 0? Right, so like we're looking at here, right? So as x gets close to 0, then let's say like if we look at 0.001, right? For instance, x equals 0.001. Then, well, y equals 1 over 0.001 squared, which equals 1 over 0.00001, which is, what's that, 100,000? So it's really big. And if you think about it, the smaller this number is, as in the smaller the decimal, then when you square it, it will become smaller still, and the smaller number you divide by, the bigger your number will get. So what we're saying is, as we get closer to the y-axis, we're going to get an asymptote going up this way, so it's going to be this shape. Okay, so that's what our graph should look like. But then also, we can look at what happens when x is negative. So x gets very small. Okay, so a very negative number. So for example, like minus a million. What happens at minus a million? Well, because we've got this squared on the bottom, so let's take x equals minus 50, say, right? Then y is going to equal 1 over minus 50 squared. But minus 50 squared, that's a positive number, isn't it? So that's 1 over 2,500. Which is very small, but it's positive, right? So as x gets very negative, y is still going to be positive, but it's going to, again, it's going to approach 0. And if you do the same analysis here, like here, okay, what happens when x gets close to 0 but from a negative direction, okay, then what you'll find is y gets very, very big again. So you end up with this shape here. And that's your graph, something like that. So it's kind of like a volcano shaped, if you like. So what have we done? Well, we've checked where it crosses the axes, and then we've said, right, well, what happens when x gets very big? What happens when x gets very, very negative? What happens when x is close to 0, when it's positive, and also when it's close to 0 but negative? So that's kind of like our new approach. And there we go. Let's have a look at another one then. Slightly different graph that might throw up some new things. Okay, a bit more space here. Right, so the next graph we're going to look at is, let's have a look at this one. Ooh. Okay, get a pen that works. Okay, so y equals 5 to the 5 to the x. Right, well again, let's start off. What happens when x equals 0? So this is the y-axis, right? Well, when x equals 0, we get y equals 5 to the 5 to the 0. Well, we know 5 to the 0 is just 1, so that's 5 to the 1, which is 5. Okay, so it's going to cross at 5. And actually, this is a graph whose shape we already know. If we write this a slightly different way, y equals, if we look at doing this bit first, 5 to the 5, all to the x, all to the power of to the power of x, which is 125 to the power of x, and you know the shape of that graph, right? Because it's like an exponential graph. But there's a slight problem with this, because the convention when you're doing these stacked powers is you do, okay, so if we write out again, so 5 to the 5 to the x, you actually do this one first, okay? So we're going to have to again take a slightly different approach to this one. So let's have a look what happens when x gets very, very big. So just as we're doing up here, so what happens when x gets big? Well, then 5 to the something very big is also very big, but it gets, this will get, because it is still of the exponential form, and if you have a look on the internet for exponentiation, then you'll see this. As x gets bigger, y gets bigger but a lot quicker, so it's like this. And again, what happens when x is negative? Well, then we'll get 5 to the say minus 2, but again we do that bit first, so that's equal to, let's say when x equals minus 2, right? Then y equals 5 to the minus 2, so that's 5 to the power of 1 over 25, which is something very small. So as x gets negative, y gets smaller. So it is that general shape, right? So in general, if we put a nice smooth curve through that, smooth than that obviously, it's, let's do that again. If we put a nice smooth curve through it, we can see that it's going to cross at 5 and go up like that. And that's the general shape. Remember a sketch, you just want to know roughly what the graph looks like. So there we go, we've looked at two graphs, which we didn't know how to sketch. We've worked out how to sketch them. And more importantly, we've got a couple of kind of like approaches. So what happens when x gets very big, what happens when it gets very negative, and what happens close to the axis, so close to the y-axis, when x gets close to 0 from both the positive and the negative direction. So why don't you have a go on sketching these, and yeah, you can bring them in once you've had a go at them and check with someone. So we've got 1 over x cubed. How about this one? Y equals 4 plus 2 over x squared minus 3. And we've got this one as well. This is something slightly different. X plus y squared equals 5. So there you go, you've got three different graphs to have a go at, and there's a website down here that you can use, really good. It can like help you calculate anything, and you can even draw these graphs using that. So you've got to be careful how you type them in, but yeah, you can check your answer there also. Right, enjoy guys.